Not a huge turnout, which is a few more people, including one of our presenters. Oh, yes. What? We have two.
Including the chair is.
Yes. Well, start with the parts. Anybody? I can monitor the demo room, but if anybody else wants to be in there too, it wouldn't be a bad thing. And okay. And if anybody would be willing to take notes. Thank you. Okay. Etherpad is fine, yeah. All right. Let's see, we'll just wait for a few more of the people to show up. So, I just saw Mo down at the cookie break, so hopefully, he just said he needs to get some sugar and caffeine before he comes up here, and I hope that's it. Exactly, yes.
Like Jeff, when I loaded up stuff in the previous session, the last exchange was CSV that never done the work and you saying, I hope they're mistaken. Oh, they're mistaken.
Meantime, I'll get the so you can see our own slides now. That's an excellent innovation. So yeah. No, we have that one here. Yeah, that's the Medico room, and that's the overhead. So kind of be doing a tennis match kind of thing here. You need notification. Yes. So I guess that's why you have two shares.
At least one of the tennis players is up behind you.
Yes. All right, so I guess maybe we can get started and hope that Mo shows up before he's supposed to present. Yes. All right, so this is Avtcore. Welcome, everybody. How does it change slides? There we go. Good. I just stopped seeing her taskbar and forgot what other app she's running. Okay, here we are. Finally, we have Mo and Bo, so two rhyming attendees. Excellent. So we have a note taker in Varun. We have a JavaScript in Jake. And we have blue sheets going around. Make sure you sign them. And there's, ooh, and our mic is turned off.
Why is our mic?
Oh, there we go.
Wait, hold on. Oh, okay, there we are. Excellent. All right, okay. So now am I on? Yes. All right, yeah. So yes, we have note taker is Varun, JavaScript is Jake. Blue sheets are going around. Make sure you sign them. And Medico is going, and we have a few people in there, Bernard and Randall. So that's good. Okay, note well. This is the exciting new note well, which, as far as I can tell, its primary difference is that we now have a new version of the RFC, which is now 8179. There's probably other differences, but I haven't read it, which is very bad because I should have. So you read it and tell me what it says. All right, so what we're doing today, starting with our agenda bash and status update, which is what we're doing right now. And then we will have frameworking with Mo. Then we'll have RM cat feedback with Colin. You look confused. Or is that just the way you usually look? Bo, are you standing up for a reason, or are you just Okay. And then we will have anything else anybody wants to talk about. So our working group documents. We have a number of working group documents which are in the RFC editor queue. We have 3 documents which are misref on bundle, so we can't do anything about that. We have 1 document which is misref on 5285 bis, which we can do something about. Yes?
Actually, you can do something about bundle. So the thing which is the last, as far as I know, issue with bundle is the RTP usage discussion. So you can go into the music list and tell people that the suggestions I sent for how to fix that are a good thing.
Yes. We as individuals can do something about bundle. We as the Avtcore working group cannot. So yes, and then splicing notification is misref on 5285 bis, which we can do something about, and LRR is misref on frame marking, which hopefully we'll do something about. Actually, both of those hopefully we'll do something about today. And then ARIA SRTP is an IESG evaluation, and it's gotten some comments. So 5285 bis. In IESG review, we had 1 open issue, which is to say, what should the multiplexing category be of this XMAP allow mixed? So the possibilities are normal, which is to say you can specify this separately for each media source, or identical, which is to say you have to specify the same source, the same choice for every source. And I think the proponents of the 2 opinions were Magnus and Ronnie, both of whom are here, which is useful. And I don't think anybody argued for anything else, which is at least something. So, I don't know if either of you want to make the case for what you argued for, or do you want me to summarize?
Yeah, so Magnus Westland. Yeah, my case for identical was basically because this is configuration on the RTP session level. Yes, you could for individual media sources or media stream has different needs, because if you bundle, you can have audio video and therefore different sets of parameters and therefore different set of IDs. But from my perspective, the whole RTP session do need to have the capability of handling both, I was saying maxed, or saying both 1 and 2 bytes allowed to be able to even handle that case anyway. So that's why and for these kind of arguments that was made, it's on about having certain, if you have a client that forwards or have independent parts which creates and are restricted, the kind of RTP session that multiplexes in single layer could actually still make it into this layer, and I don't see that everyone else needs to pay for the complexity for those entities. They should pay their price themselves. That's my argument.
Ronnie Evan. At least I know of one we had in the past such equipment that was doing the same that would probably be relevant to that. It was like connecting a video conferencing system to a phone, and just the video was going from the phone. He was doing all the call setup because it was with a PBX, and just the video was coming as RTP redirected to the video system. So, I mean, so at least I know of such a product that worked that way. And at least in my perspective, I understand what's the extra complexity. On the other hand, I mean, you can always, I mean, when you do normal, you can do identical. When you do identical, you cannot do normal, and that's the major difference, I mean, between the two options. I think there was also a comment from David Zinger, who's co-author of this original this document, and he also was for normal, as far as I know, and there was another voice for identical. I don't remember who it was, but I mean, Ecker was for identical, and that's where it stands for at the moment. I mean,
Yes,
I cannot say that I'm very strict about it, but at least, I mean, just because by the end of the day, I think that if you want to do identical, you can always do it, put it in the session level, which makes it identical, basically.
Jonathan Knight's from the floor because I'm speaking as an individual. So, I mean, I think the goal here is that, you know, we want to move everybody to XMAP allow mixed, and it's not very hard to implement if you actually have the 2-byte form anyway. So, I mean, in fact, you actually have to just kind of work to not allow mixed. So, no dying. So, I mean, I would argue for. And so I guess in the counter argument to Ronnie is that it's not. I mean, you can always say identical, but the problem is, you know, what is your, you know, it's what does your peer do? That's the problem, right? It's, you know, because in offer answer, you have to worry about what, you know, situation where you have some streams that are one way and some streams are the other way. As an individual, I would argue for identical because the goal is to move everybody to this, hopefully as quickly as possible once they're fully conformant to our BIS draft anyway. So.
Zanatti, plus one on what Jonathan said, I think we should make it identical. I wish there was even a way to not have to add this attribute and just have all implementations just do this. But I understand the necessity for the attribute. Another thing is that, you know, if you're bundled, they're coming into the same RTP stack, and they already have to be demultiplexed by that RTP stack. So clearly, that RTP stack is one thing, and it clearly has to have support for this if it was offered on any of the lines. So I think there's really not much of an argument to say that you can't do it. You can do it for one M line, but you can't do it for another if they're bundled. It doesn't really make much sense to me. So I think identical is the most logical, and it's also better to get things moving forward and new stuff.
Just to answer to more, that was the point that Magnus was making. He says if you have this problem, then the burden should be on the endpoint that doesn't support it, or the sort of the equipment that distributed that doesn't support it, to change the internally the header extension to that. And I think it. I mean, I don't have a strong feeling. So if everybody agrees on identical, I'll just send it to identical. And
all right. So I guess my question is there anybody who would at this point strongly object to identical? It sounds to me like the consensus was leaning that way. All right, let's say subject to confirmation on the list, we'll go with identical, and then hope.
Actually, we already have a start working last call
Okay,
for it in the list, and except Magnus and Ronnie, nobody comments with that. I think we should make a conclusion.
okay.
Yeah, I was going to say, this has been on the list and no one had anything to say
Okay,
until
all
now.
right, in that
Yeah.
case, I'd say let's go with identical, and so Ben, so I guess since I think we're in approved updated ID needed, is that just the authors or editors should update with the MUX category? You're the editor? Okay.
Yeah.
Okay, so Ronnie, update that with identical, and then
I'm the editor.
yeah, all right.
All right.
Okay, good. All right, so the other working group documents which aren't on the agenda today are ARIA, and all of these are things that haven't been updated in some time, so we wanted to make sure that we had some notion of what's happening with any of these things.
hi, about the ARIA, I'll check with them because I think they said that they don't have interest in SDS, but I want to verify that with
Okay.
them.
If they don't want SDS, that's great,
Yeah.
because lots of people want SDS to go away, so if we don't have
No, okay, I'll check with them about
Okay, yeah,
whether
because
they have
yeah,
an interest in
I
continuing.
certainly
this
would
work.
rather not have a fight with the security people about why we want to do new things with SDS.
The issue was that it's because the major issue was that it has to be a standard track document because of the registration requirement,
Yeah.
and that was the discussion at the
Yeah.
time.
Varun Singh, talking about multi-path RTP. So I missed one feedback that we got from Ted, I think, in April, which I just responded to a couple of days ago. but the feedback seemed like we were on the right track, and there was not much in terms of, there's more clarification for the requirements that perhaps we would anyway remove or put into appendices, because the draft was written 6-7 years ago, first motivating why we needed it and things like that. So that text can actually be moved out of the, but I think we would need a lot more in terms of feedback or reviews to, in terms of implementations, I think we've already demonstrated at least there are 3 or 4 current implementations. We've done 2 of them independently, graduate students. And I think Cisco and I forget another company, Canon had one. So in terms of that, we've already gotten feedback from implementers and it looks good.
Have they sent their feedback to the list? I mean, even just we implemented this. We didn't have any problems. Looks good. Would be
I
helpful.
think they have over the last few years.
Okay.
Now we'll have to trace back these emails, but
This is going to be a fun one for the shepherd, I'm sure.
right. I think the major part of the draft that requires substantial amount of work is the security thing. Because I think there is, of course, a new draft that we wrote for MPRTP DTLS that I think we submitted to ICE working group, but perhaps needs to come here anyway.
Yeah, I think this is the obvious home for that, since both MPRTP and SRTP are this group's bailiwick.
Right. So, and there are 2 parts to it. So people who are interested in MPRTP and DTLS interworking should read that draft. Of course, I have 1 proposal there, but there are 2 proposals in the draft. So I think people will discuss that in Singapore. So that I think is the stumbling block maybe, but I'm not the only person with the security background, so I would really appreciate any help that I can get for.
So is
for
the
this.
intention that once that's worked out, it would go into the main MPRTP draft, or would you want to keep it separate?
No, I think what we would do, because MPRTP can actually can support, because we have no security restrictions on RTP, right? So there are, there is a draft which was called, I forgot, not mandatory.
Yeah.
SRTP not mandatory. So we would have to cover the whole.
Yeah, right.
So we'll have to.
Yeah, well, I mean, but that's not the same question of whether to publish it as 1 draft or 2 drafts. I mean, you could have here's how you do, DTLS SRTP with MPRTP without saying this is the only thing you must do.
Right. I think that's a question because there are 2
Yeah, I mean, obviously
anyway.
you need to decide what approach we want to take before we put it in a working group draft. But.
Right. But it's easily referenceable, right? So we could just say informational, go
Yeah, I guess that's in some sense, an editor's choice, but just,
right.
I'd rather, I mean, sort of just I'm more comfortable pushing through, we'd either need to push them through in tandem or, as 1 document, because generally pushing something through the IESG without having a story about security is a lot harder.
We probably have a story on security.
Yeah, so I guess
I don't know how fleshed out it would be.
Yeah, and it kind of depends on, I think you said that one of your proposals took a lot more text than the other, so I'd say if it's the long one, it should be a different document, and if it's the short one, it should be the same document. But,
all right. Yeah, because it's reusing DTLS.
Yeah.
So that's my feedback. I'd appreciate if some people have opinions on security to send me some text and to get it started.
Yeah, so people, please do look at that document if you're interested in MPRTP and or security.
So, Ron, you have in the last document there, it's with me. I mean, I sat with Magnus a long time ago in Chicago, and we did some decision about how to arrange a document. I started doing it, but I didn't finish, and I'll try to finish this.
All right, I mean, this isn't blocking anything, is it?
No, it's not blocking anything, right?
Okay.
It's just because we were considering even to decide whether to continue or drop it, and because of editorship, and I said I'll finish that.
Okay. All right. Okay, I think that's it for the chair slide. So Mo, you're up.
All right. Mozenadia for Espen and Suhas and a work group, I guess, talking about version 5 of frameworking. Next slide. So just a review of what the work is. It's mostly to allow RTP switching, middle box that is not able to is able to avoid touching any of the payload. So it does pure switching. The payloads may be encrypted, and to avoid re-encryption cost, it'd be nice to not have to be able to dig into the payload. And in some environments like PERC, where the middle box may not even have access to the decryption keys. Very bizarre.
You might want to check your cable here. It's been something weird on the display.
So if you have end-to-end encrypted media, then middle box doesn't even have the keys to look at the payload at all.
No, yeah, the big display is fine, so I don't know.
It's okay. I can deal with it. But you still want to be able to make intelligent decisions at the middle box, but without being able to look at the payload. And I'll do this. And in more future-looking environments, it may even be possible for a middle box to support switching of a codec that it doesn't even know about at design time. So it could be potentially used for newer payload types. Next slide. So some of the things that it can do with these frame markings is be able to provide clean video when speaker switches. So it will know where the intra-boundaries are between frames, so it doesn't forward a bad or artifact video to the endpoints. During packet loss, it'll know how to recover so that there's dependencies met between the video frames. And during congestion, it'll be able to drop less important packets, make a better, more intelligent decision about what's better to drop towards lower bandwidth endpoints. And for endpoints, they can also get some benefits by being able to make better recovery decisions. Next slide. So this is the layout of the extension. There's two variants of it, a short and a long. So that L equals 2/0 is a length of either a 1 byte extension, which is 0, and there's a 3 byte extension when L is 2. The 1 byte only has the indicator bits, SCID, start, end, and independent and discardable frame. And then the longer extension has layer information. It has the temporal layer ID and the spatial and quality layer IDs, and then also the temporal layer picture index. Next slide. So the changes, there was two major changes, well not major, but two substantive changes to the layer ID mappings. There was discussion about getting the VP9 section right, and since it's in flux, we decided to remove the VP9 section completely. So basically what is documented in the draft now are existing RFCs, so the currently used payload formats that are already RFCs. We document what the lid mappings should be, but any new payload will document it in their payload spec. So we basically moved VP9 out, and it's now in the VP9 spec. And for future codecs, that'll also be the same. And we added some references for the current payload specs. And then also under the usage considerations, there was a discussion about how to actually do the discard priority. There's a discardable bit, but then there's also temporal and spatial layer IDs. So we added some text about when you should be able to do the discard. And then finally, it was clear that, especially from the LRR discussions, that there's some scalability structures which are too complex for frame marking to capture. So we added a section that this is not recommended for those complex structures. Go ahead, Bernard.
Yeah, I would like to see a little bit more guidance about what would be considered too complex. For example, the diagrams in the LLR document, would you consider any of those diagrams, Jonathan, to be too complex?
I think my opinion is the diagrams in the LRR document, no. Some of the diagrams I used in my slides when I was presenting about that, yes. But yeah, no, that's what I was standing up to say. I was thinking we need a much clearer definition of what too complex means.
So when we get to there's more slides on this. I have the actual text for not recommended on the next, on one of these other next slides. You can see it basically says that the hierarchical structures are fine, but anything more complex would be
Do you want
less.
to go to the next slide?
No, but we'll do more. If you don't mind, Bernard, just we'll
Yeah,
hold the comment.
yeah, my only comment is, I think for the spatial structures in the LRR document that are okay are not hierarchical.
You have non-hierarchical spatial structures?
Depends what you mean by hierarchical.
Okay, then we
I
need to
think
define that
hierarchical.
better.
Yeah.
They don't depend only on the lower layers.
Right, yeah, they depend on previous frames of the same layer.
Right, exactly. But they
It's
still,
spatial.
but they still can be made to work, right?
Right, yeah.
Okay, so maybe we can clarify the text to say temporal hierarchies,
Yeah, and
temporal hierarchical
yeah.
structures. Yeah. Okay, next slide. So the lid mapping, like I said, we removed it. It's in the VP9 draft now. And this is what we added about future codecs, that the RTP payload spec for that future format should document the lid and TID mappings, and then we refer to VP9 for an example of that mapping.
I guess it's a little bit actually standing up saying future video codecs that support temporal or spatial scalability, obviously. If you don't, then you don't need to map it.
Yeah,
I mean,
okay.
probably all future ones will, but well, I mean, I don't think like FFV1 will. So.
Yeah, I'll add a note in there that, yeah, temporal scalability is kind of built into every codec. So, yeah, but I'll make a note just to add scalable. All right, next slide. Discard priority. So this was the text that was added, that you make use of the discard bit when available. That'd be the first priority to discard. But then you can also make use of the highest values of TID and lid, because those indicate the highest temporal and spatial enhancement layers. And those layers tend to have fewer dependencies on them than the lower layers do. So it should be best to discard those first. All right, next slide. And this is what we were talking about that Bernard raised, the complex scalability structures. So it's not recommended for these structures. So here we say simple regular scalability structures such as, oh, I did say temporal. Oh, I said or spatial. Okay. Hierarchical temporal. So we need to qualify what kinds of spatial layering is okay.
In particular, I think what you want to be able to, you want to say is, what can a receiver of the stream using frame marking depend on? That's this characteristics of the stream having.
Mm-hmm.
You need to say not just, don't use it unless it specifically has these characteristics which a receiver can definitively, count on.
Yeah, Colin Perkins. Yeah, I mean the problem I think with this text is that it's not really specific enough to be actionable. It's if things are difficult, then don't do it, but it doesn't define what difficult is. So I think ideally it needs to say if you have these particular characteristics, then you probably shouldn't do this.
Yeah, I think hierarchical temporal is a slam dunk. That we can make sure that works. Beyond that, we can document what kinds of spatial work. So spatial where they only refer to lower layers and temporally in your same layer. Mm-hmm. Could also work. There's not a good name for that, so it's going to be kind of a wishy-washy description. But we can document that. But then outside of that, I don't know of anything that is really useful to guide on. Everything else to me would be kind of complex and irregular.
Yeah, I mean, I think it's probably easier to say we know the following things work.
Yeah.
And if you're doing anything else, think about it and make sure that you're not going to break anything. Rather than saying, well, these types of things don't work unless there's specific concrete things you can point to.
Okay. So we'll expand this to a couple of more sentences and get it on the list and make sure everybody's.
And I think possibly phrasing it as like Colin said, things that these are the things it is for, as opposed to these are the things it's not for.
All right. Right. Okay, next slide. So the only open issue is in the VP9 payload format. There's a P and a U bit. And in frame marking, we have I and B bits, and there's some correspondence, but it's not clear if there's direct correspondence, and it's not clear if the I and B bits are sufficient. So there's Sergio pointed out some things where implementers couldn't figure out whether or not you could recover VP9 streams in certain cases. And so it'd be useful to understand what use cases is this really a problem, and do we need to alter the meaning of the base layer sync bit in order to make it work for those cases, or do we need more bits to make it work for those cases?
Bernard's in the queue.
Yeah, I think these questions may be related to the previous one with respect to spatial. Let me try to put forward something that might make sense. I think one of the issues we were dealing with was when you drop a higher spatial layer, when can you bring it back? And one way to do that is if you're eventually going to get a higher layer that's where the P and the U bit come in. As an example, if you had, say, more than 2 spatial layers, the B bit might not be set because it wouldn't depend directly on the base, and so you wouldn't necessarily know when you could bring in the higher layer that you had previously dropped. I think that's the issue.
Jonathan Lennox actually stood up this time, speaking as an individual. Yeah, in the description you had of the hierarchical temporal structure, I believe the U bit would always be 1. The U bit is essentially this hierarchical temporal structure with slightly odd wording. So perhaps you can say that's, that bit is indicated by presence of frame marking if we want to constrain it.
Yeah, I don't think this is a problem for temporal. I think it's only a problem for spatial.
Yeah, so P is more interesting, and I've been trying to figure out is whether P is in general more useful than B for spatial scalability. And potentially we could even redefine what B means for the non-base spatial layers. But I think we need to, if that won't confuse other use cases for it.
But do you agree, Jonathan, that the issue is when you drop a spatial, figuring out when you can?
Absolutely, yes. When can you switch up a spatial layer?
Yeah.
Yeah, especially in the 3-layer case.
Exactly. Okay.
Yeah. So in those cases, then you have to switch at a spatial layer boundary where that layer doesn't refer to anything in its that has no temporal dependency on its own layer, right? So in that sense, it's well, intro is not the right word because
layer refresh. That's what we call it. That's what LRR calls it.
Yeah, not a good word for it. Not a good. I think we're going to take this to the list and figure out what we want to do about spatial scalability. And one alternative I think that we briefly discussed is having different meanings for when TID and lid values are 0 versus non-zero. Maybe that's a viable way to go. All right, so it'll remain an open issue, and we'll have to take it to the list to close on it. All right, next slide. That should be it. So we'll closing out that one last issue on the list. I think we'll be done and ready.
I think there's another open issue. I sent an email to the list asking for the non-scalable case, and there was, from my perspective, I think that we are too underspecified for the non-scalable case because there's only the discardable bit for the non-scalable. Now we did some tests with providing more information by giving priority because not all B frames, for example, are the same.
That's right. Your priority request.
Yeah. Just to finish that and the other thing was about the low motion was not in the stream, but to say this stream is low motion or this stream is high motion together with the priority, then if I have to decide which one to take, then I have more information if they have same priorities to take out from the low motion and not from the high motion when if I didn't need to drop frames. That's the reason for those two parameters there, for the non-scalable one.
Yeah, I think there was list discussion on that, and I thought that
there was no list. I just you and me. I mean, that's all discussed.
Oh, that wasn't on the list.
No,
Oh, sorry.
That was all
No, it was on the list, but you two were the only ones.
Oh, okay, okay.
It was on the list, but we're the only ones.
Okay. Yeah. So does anybody else have any other opinions?
At least I can say we did some tests with this functionality, but it produced better results. I mean, the question that is legitimate to ask is, who will mark that? I mean, for this, but we think that we should at least provide the mechanism to have more granularity for the non-scalable case, because just one bit, and we have the bits, the spare bits there, so we can use them. So we don't see why we should not also clarify. I can put text that explains all the motivation, how it works.
So is low motion sort of intended as like
it's like a conference, conference room comparing to a football game, for example. Okay.
No, the use case is sort of the visual equivalent of loudest speaker switching.
Of
loudest speaker switching, so you can do, most energetic motion switching.
No, it's more like if we have two streams that are coming through the switch, and we need to decide which one to drop, and they both have the same priority. Which one do I drop? Okay, so instead of we want to say, okay, you can try also to quantify by defining some other dimension, which may be the motion. So if you're low motion, then it's better to drop from this and not to drop from the high motion. That's all.
I mean, I saw a good point in looking at priority as something to signal. I think my feedback was that the motion aspect didn't make sense to me, because in a low motion stream, the majority of the bits are going to be very, very sensitive to drop, because if a codec is efficient, then it's not coding many bits for the non-moving parts. But the parts that do move, that small amount of low motion, if you drop that, it's going to be a very visible corruption in the main field of view, in the only thing that's moving. So typically a packet loss on a low motion stream could have a much more drastic effect than on a high motion stream, if the codec is efficient in coding the actual focal point and the detail and the moving parts well, and spinning most of the bits there. So that part I would push back on trying to add, but priority I could see as a general thing, maybe useful to have more than one bit of discard priority. I mean, DSCP gives you more than one bit, so why do we only give one bit?
Varun saying, so I got up to say roughly the same thing. I was going to say that if you have low motion, you might have fewer frames, to send. Second, if you drop those frames that were fewer, you have a bigger issue, because they tend to stay long, the artifacts stay longer, so you don't want to do that. And my second thing was going to say, like, if we could increase it from 1 bit to 2 bits, but I don't really know what those 4 bits would say, because you could say like, hey, never drop this, or and then maybe drop this, and feel free to drop this, but can't really think of anything else.
Okay, so first of all, to the second question that Varun asked, the idea behind it was that, I mean, if there are bit frame and some of them have dependencies but some don't, then you can give them different priorities, so you know which one are better to drop when you need to drop. That's the reason for that, for the priority, basically. So the information, we can specify text that explains this, the priority issue. As for the motion, I mean, one of the assumptions is that some of the system can do receiver-side recovery, and in motion, usually they just assume that the motion continues, and if it's slow motion, they continue the motion and it works, because there's not much change. I mean, and if you just take the trend and continue the motion as is, it's working. And that's what some systems are doing on the receiver side error correction.
Steve Botsko. I think what's bothering me about the whole area here is we're moving beyond what's needed to do clean switching in the RTP switch and starting to make assumptions about error resilience in the receivers. So, we're providing priorities and motion and things, so you could drop this if you want, but whatever you do in those cases, you're going to create artifacts, right? Unless you have a specific implementation where those are contained somehow. And this is a big space, right? If you have a GOP structure, you might want to know how far you are to the next refresh. There's a lot of things you might want to know if you're trying to minimize the impact on receivers, and I think it needs some more thought.
Ronnie, what we're trying to do is to make better than what this is today, because today it's just one bit that says discardable or non-discardable. So this will be the worst case. I mean, the more information you can provide by the encoder as part as the header extension, it will make it easier to discard, because anyhow the switch will discard something because it needs to discard. So the more information we provide on that, it will make it the result may be better than using just discardable bit.
Yeah, I think Steve's point was that it's maybe a slippery slope, that you start to provide a little bit more information, a little bit more, and a little bit more, and then do we start announcing the GOP structure so that you're going to get a refresh in 8 more frames. I guess there's a question of how much information to make the video optimal we should actually embed in these headers. And keep in mind, this is going to be on every single frame, so we don't want to a 40 byte extension announcing all kinds of payload stuff.
So, Varun saying again. Yeah, I was just going to say that the motion bit's also like a privacy problem, because you might actually leak information that was earlier not available, and now from a bit that there is motion and not looking at, as in you could infer that from the way the packets come or the frames come, but that's not a strong indicator of motion, and now you have this additional information.
Jonathan X as an individual again. I just observed that H.264 had a 2-bit priority or discardable field in its null unit header, and H.265 dropped that, I think because nobody found it to be useful.
That's right. Because its interplay with the other layer information was problematic. If you say the priority of this is very low, but it's the base layer, what the hell does that mean?
Right. So I mean, maybe if you don't have, but I mean, I guess even obviously lots of people use H.264 without layer information, and even then they don't seem to have found it to be.
Right. Well, but H.264 has the equivalent of layer bits. The discardable is the now ref ID. Right. So, and that's already 2 bits actually. Yeah. So they already give 2 bits of granularity.
The now ref ID was 2 bits, and they decided they didn't. I think they moved that to 1 bit in 265 because they said they didn't need 2 bits of it. Yeah. So I'm just questioning how useful more than 1 bit of discardable is. And the other thing is sort of the inverse to what was just said about motion is you can in fact, in any reasonable VBR codec infer a lot about motion just by packet sizes. I mean, obviously you have to do it sort of statistically based on, hey, this used to be big and now it's small, but you can sort of tell, hey, there's something that it's clearly decided it needs to encode a lot of bits here. So.
Ronnie Evans. So about the priority, I don't know why they dropped it, but it has to do because maybe it was done because of the scalable, but we're not talking about the scalable case. We're talking about the non-scalable. So there are no layering in that case. We're not saying that it's the base layer or dropping from the base layer comparing to dropping, but it's more like between different frames that are in the same stream. And we did some tests on that, and it provided better results in terms of what was actually displayed by the end if you made a better decision about which frames to drop if you provide this information. And that's why we don't think there's a problem with it. And as for worrying about going to other stuff, I mean, that's not what we're asking. Then if someone comes with something saying more description, then we can argue that this is the description. But to look at it and say, no, we won't do it because maybe someone will come and say this frame is something like you're going to get an iframe in 8 frames or something like that, then we discuss it at that time.
The question is just, where do we draw the line? And so the line is already drawn right now at a certain boundary, and the request is to move it to another boundary. And then and Steve's fears that, is there going to be,
Because you provide a lot
there's a
of
lot more on
information.
the other side of the boundary than
Of
just your
course.
priority.
No, but it's first of all the priorities thing. I mean, you're just saying, okay, we did just discardable, and we believe that just one bit for discardable. While for the scalable case, you define a lot of information based on the content basically. Then we're saying you can do that also on a regular stream, on a non-scalable stream, to provide more information about how these frames are, whether they are more important or less important than just using one bit for that.
Well, it's a little bit different because what you're describing, I think, is better error concealment, whereas what the frame marking is describing is non-error decodability. So in the frame marking bits, if you follow those bits, you won't have any decoding errors. You may have less fidelity because you're decoding a lower enhancement layer, but you don't have artifacts. There's no error concealment running. You don't have artifacts. What you're describing is how to minimize the error concealment artifacts, and can you assign priorities to minimize that? That kind of depends on the receiver implementation of error concealment. But I agree that there's some things that would naturally lead any implementation to have better error concealment.
Yeah, but it's being done. I mean, it's not like these things are not done. I mean, people are doing those receiver side error concealment. I mean, it's practically being used. So at least for the priority one, I mean, it's definitely there's a big difference in the result if you're taking out a B frame which is not used by anyone, or a B frame that is being used, because that's provide better, even if you don't do error concealment, to provide you better result by the end, because it just frame that reference, then it may synchronize afterwards. So I think the priority is very important. As for the motion, we were looking at more just between different streams, because the switch receives multiple RTP streams, and just to qualify something on the priority, because the priority could not distinguish between different streams. It's just inside the stream. So it was trying to give something for information between streams, and we looked at motion as something to describe.
No, I fully agree with you. There are use cases where it may be good to that, but they're usually closed. Like I'm aware of many systems that do know what the receiver is capable of, and they mark even at network layer, DSCP layer, the markings reflect the relative impairment that you're going to get on the stream if you drop this. So I'm aware of systems like that. We didn't bring any of that into frame marking because we didn't think that it would be something that was easily and widely interoperable and deterministic. I mean, it's sort of like a fuzzy kind of thing, whereas these bits you're going to have perfect decoding or you're not if you obey these bits. And a fuzzy thing like, error, artifact, level of artifact induced by dropping this is a little fuzzier, and it seemed hard to make that normative. It seemed hard to give encoders a way to actually make that normative.
And like I said, we tried to do that on streams, on different type of streams, to do the priority stuff, and we saw that the result would give us much better result if we have priority on that. And we're not just trying to say, okay, that's something we want to do.
I agree, but with your decoders, if you put it to a different decoder, you may get a very different result. If you put it to a decoder that freezes the picture on one single bit loss, right, you get a totally different result.
But that's the point. I mean, this decoder will do that anyhow. It doesn't matter what you drop. But the one who have better behavior, they can do better if you drop in the middle ones that are less, will provide less effects in the receiver side. That's what we're saying on that.
Okay, let's get some other comments and we can go to the back.
Hi, Colin Perkins. So clearly we cannot mandate decoder loss tolerance. Clearly we can't mandate decoder loss tolerance behavior in this working group. They're going to do whatever they're going to do. Yeah. Just to make this a little more concrete, can you remind us, we're just using some spare bits in the existing header, is that right?
This is a header extension,
yeah.
And there's one current bit that's a discardable bit. If it's a non-scalable stream, there are 3 other bits of temporal layer ID that could, I think it's 3. But the base layer sync too, yeah. So there's 4 extra bits for non-scalable streams. But I think what you're describing would even be valid for scalable streams, this really, to me, is independent of whether the stream is scalable or not. It's, what's the minimum disruption to the stream if you, here's the packets that if you drop, there's minimal decoding disruption. So
yeah, I think my point is we're not looking at something which is going to expand to greatly complicated mechanisms because we only have 3 bits to play with.
I mean, as far as I know, Ronnie's proposal is just adding a few bits. It's not more.
I
it's
mean,
not more than
we're
adding a few
taking
bits.
some existing bits and in the case when they're not useful for the one thing, we're using them for something else. And
It's not the bits that worry me. It's the semantics of, what do they, how could you actually mark them from practical encoders, and what would you mandate a decoder to do with it? And I don't think we can mandate either side. So it seems weird to me to have the bits.
We clearly cannot mandate the decoder to do anything different to this. Decoder is going to do whatever it's going to do. Yeah. The sender side, it's not clear to me we need to mandate anything other than just, if we say these bits are a drop preference, set them however you feel like, and there are hints to the switches for which ones to discard. And we don't have to say anything normative about how you set those bits or about how you discard the packets. You just say there are hints. It's a priority level.
Right, but I mean, I think
we need to argue about all of these details.
Will that be enough information for the switches to do something useful?
But if you don't mandate for encoders to do anything, then 90% of the encoders are not going to give you anything, and so you're going to get information coming into a switch, and it has no idea whether or not it's useful. So
you say if as an encoder you don't care, set these bits to value X. Otherwise, set them to be a priority level, and you pick the priorities, and then it will be better than not doing anything.
My view is if we have a fuzzy definition of what senders should do with this, that we'll get very little information to middle boxes to make a decision on.
You can't do anything more than a fuzzy definition because it's got to be codec independent. So if that's not useful, then don't do anything. But
that's where I'm at. That was my argument on the list.
Steve again. I'm not seeing a lot of generic use. I tend to agree with that. This is very implementation specific, what results you will get. So I'm not denying that you couldn't get good results in some tests, but I think in the general interoperability situation, that might not be so advantageous. If you do need to do something, it would be better to just create a priority field and not do the high motion, low motion, because you can always encode that as a priority if you have a specific application for it. And then people can set that priority as however they wish, and if the switch can make sense of it, then the switch makes sense of it. I agree with the comment that this applies to scalable video also, because it's a situation when the switch doesn't have the capacity. So simply layer dropping may not be enough.
Okay, so chairs, where do we go with this? Do you want more discussion on the list, or this is the only open issue that's holding up frameworking? and the other one. But I think we have a path to hopefully a week closer to the other one.
Yeah. So I guess, I might try to say, do you want to do a hum for who thinks we should do these additional bits? Ronnie, do you have a?
I think that what I heard so far is that there are two different type of bits that we proposed. One of them was the priority, and the other was the motion. I think what I heard from the motion, people don't have a good view about how the motion will help, even though in my personal view, it helps mostly between different streams, but I don't mind this one. And then there's priority, and from priority, again, it's like, my understanding from what I heard is that, and maybe we should have the hum on saying, because it provides more information than just the one discardable bit, because not all frames. I mean, currently you mark all frames that you may mark all frames that are non-iframe to be discardable in order to help the middle, but if you can provide more than just one bit for that, that would be very helpful for the switches at least.
Right. So I guess the question would be, do people think that frame marking should, in the non-scalable case, provide a priority field for within a stream, the relative priority of the packets of the stream. Is that roughly? Okay, so if you would be in, Steve, do you have a comment before we do this?
I heard two things, right? One is if you want priorities at all, and then the second one is whether or not you wanted priorities to be limited to non-scalable screens.
We can separate those if you want. Okay, so first, do you think that a priority field in frame marking to define the relative priority of various packets of the stream would be a useful thing? If you want that, if you think that would be a good idea, come now, or wait for Ronnie to talk.
I've just to comment. I mean, that has to do with what's called. I'm not sure we can add it to the scalable because I don't think the bits are there. Okay.
Well, I mean, we can always make it longer.
Okay.
Yeah, let's forget about the encoding for now.
For the non-scalable, the bits are there. I mean,
Yeah,
they're not used. Okay.
Yeah, well, let's forget about the, my concern is not the bits. I think we can worry about the encoding later. My concern is the meaning and the semantics of this and
Okay.
what,
All right. Okay. So
what the use of it is.
all right.
The meaning of the priority of it is going to be very fuzzy. Like we said, we cannot mandate, we can't write anything normative about the priority. We can just say that it's the relative priority, higher values, mean,
The
less
decoder
priority or
wants to
something.
put. I mean, that's all. I mean, it's
Just
just
relative
it's
priority.
just going to say you must do this. This is this priority. This is this priority. It's up to. We can provide some text to give examples, but that's all we can do about it. I mean, it's not like we're saying this is the way to use it.
And just to clarify, to make sure everybody understands, this is something totally different from the rest of the frame markings because the rest of the frame markings are trying to say you will be guaranteed to have a decodable experience if you do this. There is no decoder, any conformant decoder will render what you're doing. But what this is different. This is saying this is relative priority, and these things may or may not be decodable by some. The behavior of a decoder is not guaranteed to be relatively better.
I'm a bit confused in the scalable case if the priorities would actually make sense because it seems like the middle box may be more confused if it sees a priority bit being something, and then it anyway needs to look at the layer to see what decision it wants to make. And I'm not sure if the priority bit makes sense there as an.
So to what you're saying, in the scalable case, there's still the discardable bits, and the discardable bits can be for a frame inside the layer. So you have the same problem there. I mean, it's like you can still get a non-decodable string if you just mark some of the frames inside the layer. So
Under frame markings, you should deterministically know whether something is decodable or not. If something is discardable, it means it's truly discardable. It has no references. Nothing else will reference it.
Colin Pickens, a reminder, this is running over an unreliable transport. You may always end up with an undecodable stream, whatever you do here.
No, but as a receiver, when you get all of these, you know whether or not as a receiver in the SFU, you got these things in sequence.
You have sufficient information to know whether what you have is a decodable stream.
Yes.
So the drop priority, right? I mean, at this point, you are going to be dropping a packet anyway, right? All this is saying is pick which one you're going to drop. You are damaging the stream at this point.
So,
and the other packets may be lost in the network anyway. So don't worry about whether you end up with something which is decodable or not, because you don't know what else is going to get lost.
all right. So are people ready to take the hum, or do we have more comments before we do that?
Do you have a question?
I think the question I'm going to ask, semantically, without worrying yet about the encoding, and leaving aside the question of whether this makes sense or scalable. I guess let's just say specifically for non-scalable. I'm not, without asking the question of whether it's a good idea for scalable or not, but specifically for non-scalable, do people think it would be a good idea to have a priority field in the frame marking header? If you think it would be a good idea, hum now. If you think it would not be, hum now. That sounded like louder against, and there was one against on the Jabber room. So I am thinking, what did you say?
I said it's not strong.
It's not strong, yeah. So, I mean, it sounds like,
There's no clue.
Yeah, I mean, it's not a, it's, there's certainly not a preference for it.
I'm trying to understand why people say it's not. I mean, we have this bit, we have this information. I don't
Yeah.
understand.
So
It's
my
not good to have this
yeah,
information. That's
I,
what I'm
so
not
I mean, my suggestion might be, I mean, I think it's probably what it already says is must be 0 on transmit, ignored on receive. And so if in the future, so if we have those square bits and a future update to that could,
But that's what the text says.
what? Yeah, so that's my point. So my point is that this could be added, you know, without breaking backward compatibility in the future if people decide.
What I'm saying, I don't understand still. I mean, what is the objection? Because if I want to come back and say something, I want you to understand why people object to having this in the stream. I mean, because I don't.
Ronnie, use the mic, please. So, yeah.
You asked for harm, who's for and who's against. Okay, so I still don't understand when people saying they don't want it, why they don't want it, because we are not doing anything that will change the frame marking in terms of the format. We're not saying to change any of the structure. We're just saying these bits are not used. We want to use them for that. That's all we're saying here. I mean, and we don't even say there is some semantic entitlement to that. We're just saying this is something that may help a middle box in order to decide which frames to drop if it needs to drop, and not just have just one bit, which is it's less than having 2 bits to define which one to vote. Because we have a discardable, but we use 1 bit. Why did we choose 1 bit? It was probably because that's what the structure was made. But we could have defined 2 bits or 3 bits for discardable. I mean, same thing.
Varun Singh. So I hummed for it, and I think for the scalable, for the non-scalable case, I think there might be value for having a priority bit. In the scalable case, I'm a bit more confused about it. I think adding an extra bit in this case would actually benefit systems because you don't have the GOP structure, you don't know what's going to happen. There might be some extra information in addition to the discardable bit in those cases. Yeah, that's what I got up to say.
So what's the result of the hum?
What, say again?
So what was the result of the hum?
The result of the hum sounded to me like moderately opposed, but not what I would call consensus as such. So I don't know. AD advice? Oh, we have a comp.
Jake Holland, I just have a question. Would anybody who was opposed change their vote if it were clear what exactly the switches would be doing with the frames that with this priority? My question is, anybody who was opposed, would it change your vote if there was clarity on how exactly the switches which might use this information to drop the packets would make their decision to drop these packets?
I think it would take more than that. I think it would also take more clarity on the sender requirements for marking this. And keep in mind, I mean, this is just a header extension. If you have a system where you know the sender and the receiver, and you know their loss concealment algorithm, you're perfectly fine to send a priority header yourself in your closed system with a custom URN in your extension map, which is what a lot of systems already do today. Hint, hint. So that to me seems a viable option if you know how your decoders are going to respond, and you know the relative priority of the stuff at the encoder. You can have your own header extension that does this. I'm not necessarily convinced that a standardized frame marking for all systems would be that beneficial, because there's just too much different behavior out there.
Okay, so Colin Quicken. So my impression is we're going around in circles here, and I am not in the group seeing consensus to add this, and I think we can add it later in a backwards compatible way. So, you know, my suggestion would be that the group move on with the thing as it is, and we can always revise this later if we need to, and come up with a strong requirement and agreement on how to do it.
I don't mind, but what I hate to see is that I will go back to the list again and try to explain this, and there's no response, and we come again to the next meeting, and I'll stand in the mic, and we go through the same process again. So I don't know.
Well, I responded. You need to get more responses from others, I guess, on the list.
So, Balazs, right? So two things. In the congestion control perspective, if you are dropping frames or dropping packets, it must be as soon as possible to react. And in the other things that it's coming to my mind that in a path awareness working group or research group, which was it was Wednesday, they said that in the middle box in the network, it must be as simple as possible. So if you are adding a complexity which must be examining that whether the frames or packets must be dropped or not, it should increase the complexity. Just keep in mind that
the middle boxes are already complex in this case because we're talking about a scale SFU or something which wants to drop it because then they
yeah, just keep in mind that it must be as simple as possible, so not increasing unnecessarily. That was my only comment in the second aspect.
Yeah. So we are in fact 25 minutes over this
Wow.
time schedule for this item. So
People have flights to catch too, probably.
So what Ronnie said, let's not do. Let's not go to the list and have this not resolve and be talking about it next time, right?
I agree. Yes.
I can't tell, is there anyone that can't live with Colin's proposal about not adding it now, but maintaining the extension points so we can add it without breaking backwards compatibility?
The text is those bits are free currently for the rest of it.
Yeah. Okay. Yeah. So Ronnie, if we did do that, saying Colin's proposal, which is say the text as it is now, would you be disappointed but not jumping up and down?
I will not drop that down because
Yeah.
you couldn't understand what the
Okay. All right.
Even from what
Okay. So my inclination is,
today he was saying,
Yeah.
people are doing it, but they're doing it in
Yeah.
non-standard.
Right, yeah, so-
Why should we put this bit around those ones who do it standard?
Yeah. So
I think wasting 8 bits when you could just get one now.
yeah. Well, yes.
Well, I'm saying, so if you're suggesting that we can do it in 8 bits somewhere else, and here you can do it in 1, I think
No.
that
No, what we're
makes me-
saying is that these bits that Ronnie wanted to grab are going to be defined as must be 0 on transmit
Sure.
and must be ignored on receive. So if we later want to redefine them, existing endpoints will not be harmed.
Yeah, I think my response was more to Mo saying that you could send it.
Yeah,
as an
you can
ex-
also do it as another extension header, and that does cost more bits, but gives you more flexibility. So either one is doable. So, I mean, yeah, personally, my inclination is to say, let's not do this now, let's get this document done. And Ronnie, I suggest talking to people offline to figure out what their objections are.
All right, thanks.
And Colin, you're up, only half an hour late. But fortunately, we didn't use the whole agenda slot.
Hi, my name's Colin Perkins. I'd like to talk about the difficult and controversial draft now. So, hopefully I'm joking. So this is a draft on how to use RTCP feedback for congestion control. It's come out of the RMCAT working group. The authors of the draft are myself, Zahid, Varun, and Michael. But this is an output of a design team in RMCAT. Okay, so the goal here is to provide a means of getting feedback for the congestion control algorithms in RMCAT. So we want to give detailed feedback on per packet loss events, arrival times, and explicit congestion notification bits for every packet in an RTP stream. We want to send this at some rates, which will probably be every frame or every couple of frames for video, maybe once a second or so for audio. And piggyback that into RTCP by playing with the RTCP bandwidth allocation to get a reporting interval that matches the rate at which you want to give feedback. Now, in terms of RTCP timing, I don't think there's any changes needed. I think we can use RTCP and all the existing extension and configuration points as is, and I don't think that we need to do anything in this group or anything in terms of signaling. But in terms of feedback, we do need to define some new packet types. So we're here to get some feedback on how to use RTCP to do that. Next slide. So obviously, RTP endpoints will send regularly scheduled RTCP packets. The frequency at which they do that will depend on the allocated RTCP bandwidth, and we can tune that, tune the amount of bandwidth we allocate to get feedback as often as we need it. The scheduled reports will be compound packets. If everyone implements this according to 3550, they will begin with either a sender report or a receiver report. They'll have a source description packet, which has at least a CNAME item in it and maybe other SDES items, and they may be followed by other RTCP packets in the compound. What we're proposing from our MCAT is that we define an XR block which provides feedback on congestion state that can be put into these compound packets, and also some non-compound stuff, which I'll talk about in a minute. Next slide. So the proposal for the XR block looks like this. You've got the standard XR header for the first 8 bytes, which is straight off the XR RFC. We've got a 8 bytes of congestion control report header, which are a block type, a report count, which is how many SSRCs you're reporting on, a block length, and a timestamp, which is the time at which this report is being sent. And then for each SSRC in which you're reporting, you have begin and end sequence numbers, which identify the number of packets you're reporting on. And for each packet, you have a 16-bit chunk, which contains 1 bit to say whether that packet was lost or not, 2 bits for the ECN, to echo the ECN bits from that packet, and an arrival time offset relative to the report timestamp. Obviously, if the packet was lost, the ECN and the arrival time offset are just set to 0 because they're meaningless. And if it wasn't, they tell you the ECN and the timing. And that just repeats for everything between begin and end sequence numbers, and it's padded out to 16 bits with zeros if necessary. And we just stack them up for every SSRC in which you're reporting. Okay, slide. Now, we're defining this as an XR packet. We could obviously define this as a new RTCP packet type rather than putting it in an XR block. If you do that, you save 4 bytes here. And that gives you a small saving in bandwidth. It's beneficial if when use. If we can use, because autocorrect is a wonderful thing, if we can use the same format for the early feedback packets that are sent in the non-compound packets. Otherwise, it's not clear to me that that's beneficial, that it's worth doing, although we do save 4 bytes if we do it. Next slide. The primary reason why I don't think this is worth doing is because we're putting these into a compound packet anyway. And by the time you've got your sender reports, your report blocks, your source description, your CNAME, your IP header, your UDP header, you've got 80 odd bytes of overhead anyway, and saving 4 bytes for the using a custom packet type rather than XR, or indeed optimizing the format here doesn't actually make a whole lot of difference.
Yeah, I had a comment. I think there's another reason why the custom would actually probably work better, and that is that XR is not getting much take up in terms of deployment, and so I think the odds of implementation will be higher if you just use the custom RTCP.
Yeah, well, that I can't judge, but I mean, it makes very little difference which one we pick, and yeah, so we could easily switch to a custom one if people think there's benefits.
I think it will increase the chance of deployment.
Sure. Yeah. Okay. Next slide. Unless there's anything else. Okay. If we want to reduce the overheads of doing this, the most effective way of doing that is just to send non-compound packets rather than always stacking these on the compound packets. So you know, I had a presentation on that in RMCAT earlier in the week where I worked through this, and if you can look at the slides for that presentation, and it shows that you actually get pretty big bandwidth savings by interspersing by alternating non-compound early feedback packets with the full compound packets with everything on them. And yes, you still need to send the scheduled packets, but you know, the scheduled compound packets, but you send the non-compound packets in the middle, and that gives you a tremendous bandwidth for it. Next slide. What we're proposing for the non-compound packets is to use the transport layer feedback format. We've taken exactly the same information that was in the XR blocks in essentially the same format, and all we are doing is we've slightly rearranged it. We put the timestamp at the end rather than at the beginning to fit the format of the transport layer feedback. So it requires us to slightly rearrange the packet formats, but it doesn't cost any more bits by using this transport layer feedback. And we've just stolen block type 2, which is the next unused value. And well, we should probably ask Guyana to do that, but yeah, that's the one they would allocate by default.
Because I don't think we have.
Okay, well, we'll pick 3 or whatever it is.
Whatever. The next, because I don't think we have anything. This is the RTP, the RTPFB, not the PSFB block, right?
It's the transport layer.
Transport
feedback,
layer,
yeah,
right? Yeah.
rather than the payload specific. Yeah. So I think the only one defined is generic NAC, which is 1.
Yeah, I think
And
2
this
is
is
reserved
2.
because people were trying to use it for ACT, and then they decided ACT was a bad idea.
Yeah.
But,
So this number will be whatever is the next unused value in that space.
So I just wanted to make sure that people understand, like, why wouldn't, if we made it PT something else, would it matter?
I mean,
just for
if we use, instead of doing it as an XR block, we could define a new RTCP packet type. We could put exactly the same information in. And if you go back a few slides. On that one.
Yeah.
So, I mean, we would essentially define it like this, and you could send the same thing in, well.
So I just had a question. Was it
It's-
mainly because of the early feedback?
It's early feedback, which, if I'm remembering right, says you should use one of these feedback formats.
Yeah, I know. That's what I just wanted to make sure that we understand why we do 205 and not its own format.
Yes.
Is that we might want to use the early feedback in some
Yes,
cases.
exactly.
Nothing stops us from letting us define, say that. Well,
Sure.
let me say I should be at the mic, but I don't feel like it. So there's 2 points. One is I think there's something stopping us from saying any new feedback type we say can go in either place. And the other thing is there's nothing that stops you from putting a 205 in a regular compound packet. That's generally what you're supposed to do if the next thing, if you have a compound packet coming up. So you could say that you don't need the XR block at all. You could just say you have this compound packet and you put it in, you have this new feedback type and you put it either in a compound packet or a non-compound packet, depending on what's happening scheduling.
Yeah, I mean, if that's legal, we could certainly do
Yeah,
that.
I mean, you know, that it's so, and I mean, my inclination as an implementer would be, I would rather not have 2 different types of RTCP packets to parse and encode for exactly the same information.
Sure.
Right. Actually, that was the clarifying question.
Yeah.
I think 205 was the only one which does early feedback. I'm not sure. We could, of course, write it in a way where we would say, like, this updates the 4585 that it's not only 205, but also this thing that can do early feedback. But since we have so many FMT values, we could do that.
Yeah, I mean,
also.
there's plenty of space there. So
Sure.
if we can use the 205 format in a compound packet, then that may well be the easiest solution.
You can.
Yeah. Okay.
In fact, I think you're supposed to.
Okay.
Yeah, then you do early and then you do it on schedule.
Okay, Jahed, as a design team member, I think what Jonathan proposed makes more sense to me.
Using 205.
I mean, using one, so people don't have to like parse 2 different things to get the same information. That makes quite logical to me.
Sure.
So the question now is if we do 205 or do something.
Yeah.
Or like something.
I think that we can figure it out.
Yeah.
Pretty easily. That's not a big issue.
It's probably easiest to, it probably requires the fewest changes to other documents to do 205.
And it probably also, it fits best into what people are already doing for their proprietary congestion control. I think they're typically using 205 or 206 packets for that today.
Okay. Okay. If we can skip on probably to the last slide. Yeah. Okay. So we've proposed some formats. The questions for the working group: is the encoding in XR and transport layer feedback appropriate? And it seems to be that the steer is that we should just use transport layer feedback for everything. Okay, that's easy. And the other question is, who's going to do the work? And should this be adopted in AVT core? If not, should our MCAT do it? And if we believe AVT core is the right home, should it be a working group draft?
Magnus Westland. Actually, one comment before on the previous kind of subject. I mean, I don't think there's anything that prevents you to send an early packet, which isn't an XR block either. It looks a bit odd, but I think it's actually not strictly forbidden in any form. It's just an early packet is just a packet, an RPC packet you send early. It's.
I thought there was something about the feedback that required it to be that packet.
No,
So
I'm fine with the 205 also because
yeah.
it looks like it's actually quite appropriate for this type because it's transport feedback, etc. So it's fine.
It's also slightly lower overheads than the XR block.
Yeah. So, anyway, on where the work is put done, I think AVT core is suitable for doing this. And I see no problem with taking it on as a working group soon as there's some reason to be. Yeah, there already exists a draft for it, I assume, so it can be adopted fairly soon. But maybe you should take the steps of moving towards what's been discussed here.
Sure.
So just going back to the non-compound thing, I think non-compound you can send any time. I think the early feedback can only be sent in 205. I would prefer to use the 205 because maybe the timers and like all the recalculation and everything is done on that particular thing. You would not have to write a new code structure where you would say like if 205 and something else. So, so I might prefer that.
Yeah. My guess is people have probably implemented 205 for other reasons in their applications anyway.
Right. So. Yeah, they do, of course. I had another question. What happens if something that was lost gets knacked in the format? And in a previous report, it was 0, and the next one, do we report on it or not?
We report on it. What the congestion control candidates do with the conflicting feedback is up to them.
Okay.
Yeah. Also, if you're doing things right, that should be a separate packet sent on as an RTX packet or whatever sent on a different SSRC, ideally.
Moses and Maddie, I agree with Magnus to do the work in AVT core because I think this could also be useful outside of congestion control. I'm getting good ACK vectors for packets is useful for even encoders. The frame marking stuff is very simple drop decisions for middle boxes, but if encoders had full information about what was ACKed and what's NACKed, then they could make better decisions about what the dependency trees of the receivers are.
Sure. Okay. Okay, so what I am hearing is we should change this to use the 205 packet format, and it sounds like we should be thinking about submitting it as an AVT draft.
So I guess to formally do that, does anybody? I won't do it as a HAMA because I haven't heard objections. Would anybody object to taking this on as a work item of the AVT core working group? I don't see any. And B, does anybody object to taking this draft module of the changes we've done as the starting point for the working group draft?
Again, Jahid, design team lead now. so our job will be we'll take the comments from here and submit a new version as AVT core.
Well, I mean, why you submit your individual drafts? So yes, I think you were saying you take the comments from here and submit it as IETF AVT core, as a working group document of AVT core.
Okay.
And
probably the easiest is if we take the comment to change to 205 and then do that as an individual design team draft, and then take that and rename it as an AVT core draft.
Okay, as you wish.
Okay. Yeah.
But yes, I mean we'll confirm that on the list. But yeah.
It might be worth asking who will be in review.
Oh, yeah, yeah, that's a very good question. Who is willing to read and review these documents? I see Magnus. I see Mo. And anybody remote? Bernard? That's, plus the design team themselves, which is most of the people we usually get in ABT regardless. So. Yeah, so the design team themselves are obviously going to write and review.
Yes.
So.
Balash, right? May I have a question? So,
Sure.
So this is congestion feedback is very good, and it would be increasing the interoperability between the congestion controller using. So let's say that two sides are using two congestion controller. The only thing which is was not clear to me is the clock rate or in the timestamps, because if they are using the two congestion controller using different clock rate for generating the arrival time offset, the whole thing cannot be useful. So it's useless.
If I remember correctly, the draft currently says to use millisecond timestamps.
Yes.
We can argue over what the appropriate rate is, but it uses a single rate for everything.
No.
Yeah.
I mean, you have to decide what the granularity is, which I'm sure people will fight about, but. Yeah.
Okay.
It is defined in the draft currently, and I think it's defined as milliseconds, and we can argue whether that's the right choice.
Jahid, yeah, I think we have discussed this. I think this issue has been raised in the design team. We have discussed this, and I think the draft actually has the sort of answer to that one. Some Colin said we pick up and value for it, and so far we have not heard anybody objecting. So I think draft clarifies what you are asking.
I mean, the Google Stefan Holmer's proposal used a different timestamp resolution, so we can argue about the resolution, but.
Yeah. So just to clarify, this is the delta offset from when the RTCP report was sent.
Yes.
And when the RTP packets at the receiver were received. So it's completely in the domain of the receiver's clock. And if I remember correctly, it's 13 bits. 2 to the power 13 is 8192, or so in this case, you can encode up to 8 seconds of data in so I think that should be sufficient if we.
So we're assuming you're sending an RTCP report more often than once every 8 seconds.
Right. And I think that gives us enough room, unless if you were sending it less often. Right. So delta offset for the auto, the arrival time offset from the moment and the report is generated, right? Yeah. Yeah, but the report have a timestamp, report timestamp. That's timestamp. Yes, but in both cases, this kind of report timestamp must be from the same clock rate, right?
No, so the report has a timestamp.
Yes, that's right.
The offsets are relative to that timestamp.
Yes, that's I understand.
The timestamp and the offsets use the same clock rates, as I understand it.
And all reports from the same sender use the same clock.
Yes.
And yes, we need to make sure all this is consistent and has the right rate and all of that. But yes.
Maybe
And
I was a little bit fuzzy in that.
If it isn't consistent, then we will obviously fix it.
Okay.
Yeah, but yes, that's just a detail we need to resolve. But yes, we
Yeah,
will make sure
okay.
it's fixed.
Thank you.
Yeah, I think read the text. If you have some suggestions or you need something clarified, just send us. Okay.
Yes, I mean, it may well be that we end up with something like the middle 32 bits of an NTP timestamp, which is what some of the sender report stuff uses, I think, for the base timestamp and then offsets relative to that, or something like that. But we'll figure it out.
This is something we can argue about in the working group at length.
Yes, and not in the next 10 minutes.
Or
whatever.
2 minutes, I think, or so.
They're already drafted, covered.
Yeah, and I think, my inclination is to keep the existing design team as the authors of the working group draft. If you're assuming you agree.
Sure.
Okay. So I said my inclination is to keep the existing design team as authors of the working group draft, assuming they agree and assuming it's a few enough people that I know won't complain.
Keep the current offers.
Keep the current authors, yeah.
Okay. Yeah.
All right, so yeah, we'll confirm that on the list, but it sounds like we have consensus on adopting that.
Sure. And as with my RM Catcher hat on, if I could make a request that when you last call it, you also send that to RM Cat.
I will ask the author of the draft to remind me of the time.
Okay. Good.
All right. Okay, I think that's it for this.
I have one additional thing.
Yes.
Magnus Westland. So, Gory Fairhurst has actually written a draft about PathMTU discovery.
Mhm.
Again, packetization layer for datagrams.
Mhm.
It's in TSP working group, individual currently. That's algorithm plus individual methods for particular datagram usage on how to do PathMTU probing.
Okay.
I would encourage people maybe look at this. We had some discussion around UDP, RTP, etc. What you would use for this, and actually, one inclination there would be actually go towards using stun. But you can think about it and maybe comment to Gory. I think he would appreciate getting more feedback on this.
Can you forward that?
I can send them the draft to the list. So,
Okay, great.
yeah.
Actually, the other thing I guess I would raise as an individual, if you'll remember from Chicago, I had a draft on 2 new code points for BTLS SRTP, which were basically things that were there in SDS but got missed in BTLS SRTP. I'm pretty sure by accident, which is the AES 256 with SHA-1 as opposed to GCM. The feedback I got is that could be it doesn't have to be a standards track. It could be informational because of the registration policy, but nobody else had any opinion of whether I should try to bring it here or just push it through some other means. So if anybody has an opinion about that, let me know. This is my draft. I think I published it. I sent it right over this, but it's the so AES 256 with SHA-1 as opposed to AES 256 Galois never got a DTLS SRTP code point, and I'm pretty sure that was by mistake because it got because of the relative. They didn't want a draft dependency between the 2 drafts, and but.
Mo, I assumed it was a mistake earlier too, but I thought a meeting or 2 meetings ago, Colin got up and said there was a purposeful decision to restrict new registrations to things that are absolutely going to be used, and they thought that you're going to be using something new like AES 256, you should move to the new suites like GCM.
I mean, if they
That was wrong?
I would believe that if the IANA registry policy wasn't specification required, as opposed to standards action. That's why.
This is Ben. Have you talked to Ecker?
I did. He said his response was basically, "Yeah, I guess so," which he didn't sound like he was paying a lot of attention to it, but neither did he object to it.
Okay, so he is. I believe he's still the designated expert for that IANA thing, and he has been on the very much in the let's not register things we don't need lately. So I kind of think it's SHA-1 really.
But it's, I mean, but it's HMAC, so HMAC is fine for HMAC MD5 is still fine. You can't break HMAC. You have to do a really complicated preimage to break.
I think are people going to use it question is more important.
Fair enough. So, I mean, I did this because, I was telling people, hey, we have to move to DTLS from SDS, and they said, but they said, well, we're doing this encryption now. Can we still do that? And I said, well, no, you'd either have to move to GCM or go back to AES 128. And they kind of looked at me sad. Yeah. So. I mean, I'm trying to convince them that move to GCM is the right answer, but that's a little bit of a harder lift because we have to implement it first. So, all right. Anyway, I guess the question is just if we do want to do it, what do I do with the draft? Because I could AD sponsor it, but given that this is a perfectly good working group that could do it.
Are you looking for review?
Sure.
I mean, do you need the overhead of the working group to register a code point?
No. I mean,
Because
review
Edgar's
is-
going to have to look at it one way or the other.
Yeah, sure.
So I'm okay either way, but
Okay.
it seems a little heavyweight to make that a working group item
Okay.
unless you think there's some something to discuss.
No, I think basically it's, it's either what to do if you're going to do it is obvious, and then you either do it or you don't. So yeah, would it be through you or? Okay, I'll talk to you offline if I get around to it. Or I'll decide I don't care after all. All right, with that, any other issues anybody has? If not, well, that's it for, other than people who are on the iStar, we're done with the IETF, and see you in Singapore. Yeah, I know, we're 5 minutes over.